Hey, welcome to The Explainer. Today, we are going to crack open one of the most powerful ideas in all of mathematics. It's a concept so fundamental, it's behind everything from graphing a simple line to programming the computer or phone you're watching this on.
So what is this massive idea we're talking about? Well, think of it as the one thing that brings order to the chaos of numbers. It's the rule that lets us build reliable, predictable models of the world around us.
Right, we're talking about the concept of a function. And you know what? At its heart, the definition is incredibly simple. So simple, in fact, that a lot of us try to make it way more complicated than it needs to be. But we shouldn't.
And that's it. Now really, that's the whole definition. You put one thing in and you get exactly one thing out. For now, let's just stick with that. Don't add anything else. This is the foundation for everything.
One input, one output. Seriously, burn that into your brain. If you walk away with just one single thing from this whole explainer, let it be this phrase. It's the key that unlocks pretty much everything else, and you'll see we're going to come back to it over and over again.
Okay, so to really talk about functions properly, we kind of need to learn the language, right? The lingo. Now, these words might sound a little fancy, but trust me, they're just labels for ideas we're already getting our heads around. Okay, so every single function has two main characters, the input and the output. You can think of it like cause and effect. The input is what you start with. We almost always call this x. And the output is the result you get, which we usually call y.
And here's where it gets kind of cool. We have special names for these. The input x, we call that the independent variable. Why? Because you are independent. You get to choose whatever value you want to plug in. But the output y, that's the dependent variable, because its value totally depends on what you chose for x.
All right, so what about the collection of all the possible inputs you're even allowed to use? Well, that has a name too. It's called the domain. Just think of it like the function's home turf, all the valid x values it knows how to handle. And it just makes sense, right? If the domain is all the possible places you can start, then the range is all the possible places you can end up. It's the complete set of all the outputs that the function can possibly spit out. So, super simple, domain is what goes in, range is what comes out.
All right, enough with the theory and the definitions. Let's make this concrete. We need a real-world example, something we can all relate to. How about getting paid for a job?
Okay, so check this out. The hours worked column, that's our input. And the pay received, that's our output. Makes perfect sense, right? You put in the time, you get out the cash. For any specific number of hours you work, you get one and only one specific payment. But wait a second, you might be looking at this and thinking, hey, 30 hours and 40 hours both got a payout of $490. Is that allowed? And the answer is yes, absolutely. That is perfectly fine. It doesn't break our rule. Why? Because the input of 30 hours still has only one output, $490, and the input of 40 hours has only one output, $490. And no confusion, it's still a function. Okay, now let's imagine your boss is, well, let's just say a little unpredictable. Imagine this scenario. One week you work 30 hours, you get paid $490. Okay, cool. But the next week, you work the exact same 30 hours, and you only get $310. Uh-oh. See? This is where everything falls apart. This breaks our golden rule. Our one input, 30 hours, is now pointing to two completely different outputs. It's not predictable, it's not reliable, it is not a function. You can't depend on it, and that's the whole point of what a function is supposed to fix. Okay, so now we get the core idea. Let's put on our detective hats. How do we spot a function in the wild? Like, what if we're just given a bunch of data points or an equation? So when you see a set of points like this, your first move as a detective is to look at the inputs, the x values. Okay, we've got -2, -1, 0, and 1. Do you see any of those inputs repeated? Nope. Every single one is unique. And if no input is repeated, there's just no way it can break our rule. So, case closed. This is a function. Okay, now what about this one? Whoa. Red flags, alarm bells should be ringing right now. Look closely at the inputs. We have -2, and then we have -2 again. And that one input, -2, is trying to be in two places at once. It's mapping to 5, and it's mapping to 6. That is our rule broken right there. One input, two outputs. Definitely not a function. All right, but what if you just have an equation? How do you test it? It's actually a pretty straightforward two-step test. Step 1, you've got to solve the equation for y. get y all by itself on one side. Step 2, you hunt for a very specific red flag, a little symbol that just screams, I'm not a function.
And what is this troublemaker? What's the red flag we're looking for? It's this guy right here, the plus or minus symbol. This thing is the dead giveaway. The moment this shows up when you're solving for y, you know you've got a problem. It literally forces one input to create two outputs, one positive, one negative, and that shatters our golden rule.
So, where does this pesky plus or minus even come from? Well, it pops up when you have to solve for a variable that has an even power, like y squared. See, to get y by itself, you have to take the square root of both sides. And here's the crucial part. Whenever you are the one to introduce a square root into an equation to solve it, you are mathematically required to add that plus or minus in front. And that is the exact moment a relationship stops being a function.
Okay, so we've gone through the definitions, the real-world examples, the detective work. After all of that, what's the one thing, the key takeaway that you have to remember?
It all comes back to that mantra we started with. A function is all about being reliable. It's a promise. It's a guarantee that for every one input you use, you are guaranteed to get exactly one output. That predictability is what makes functions one of the most powerful tools in all of math.
So think about that for a second. This rule creates predictability in math, right? But where else in your world do you see this? Where does a single input guarantee a single, reliable output? Hitting the play button on your remote, scanning a barcode at the store, turning a key in a lock. This idea, this functional relationship, it is literally everywhere. Thanks for watching.